Good morning everyone. Welcome back for today's lecture on composite materials. I, R. Ranjit Kumar, Assistant Professor of Mechanical Department, Vignan Institute of Technology and Sciences, welcome you for today's lecture. Before getting into today's lecture, let me give you a brief recap about the previous topics. Till previous class, we discussed about various manufacturing techniques like wet layup method, spray up method, resin transfer molding, film infusion, resin film infusion, prepregs, autoclave and so on. And from today we are going to discuss about various types of reinforcement materials. What are various reinforcement materials we will consider here? Fibers, right? So, fibers are our reinforcement materials which we are going to consider. How many types of reinforcement materials are there? We can list out n number of reinforcement materials. There are n number of reinforcement materials which are available to us. But whenever you want to classify some types of reinforcement materials, then we will be having a very short list of them. Let me give you a list of that. Glass fiber being the first one, second silica fibers, third Kevlar fibers, and the fourth carbon fibers, fifth boron, sixth the fibers made up of silicon carbide, and seventh the fibers made up of boron carbides, right. Moving on to the next slide. Now today let us initially consider the first type of fiber. What is the first type of fiber we are considering? The glass fiber. The first type of fiber we are considering here is the glass fiber among this particular list. So when we want to discuss about the glass fiber, we about it, how exactly, when and what made the glass fiber to come into existence, and then what are the different types of glass fibers, and along with that we will also see what are the applications and how to manufacture these glass fibers. Okay. Now today when you consider applications, industrial applications for these particular composite materials which are using glass fibers, almost all the materials, almost any specialization, let it be constructional field, let it be structural engineering, or let it be manufacturing of some components, let it be preparation of some automobile components or aircraft components, so what not, you name a thing that will be having the application of this particular glass fiber, right. So as it is explaining here, as you are observing here, almost any specialization for materials, structural materials can be obtained or can be met, or the strategies can be fulfilled by mixing up of or by considering the combination of glass fiber along with plastic resins. So glass fiber is acting as a reinforcement material and plastic resin is acting as a matrix material, right. So glass fibers when mixed with plastic fibers, plastic resins, we can meet or we can reach the expectations or we can match the expectations of that particular specialization of the structural material. And this type of materials will have outstanding properties, many outstanding properties. They are not limited to a few. There are lots and lots and lots of properties, enhanced properties. Okay, right. Next, when was this glass fiber actually brought into existence? Who found it? Who brought this into, who brought this glass fibers into application points, right? During 1942, you might have remembered that when we started the very first class, when we discussed about the definition, the history of composite materials in the very first class, I have said you that a person named Owens Corning, he observed and he observed that these fibers or these composite materials will be the future of the society, will be the future for our present industry, right. And then he set up an industry, that textile industry, right. He set up an industry That was somewhere around in the around in 1942s, right? So then the first glass fiber was actually found or actually used in fabricating a structural aerospace component, right? And in the early 1960s, high strength glass fibers, though they are glass fibers, high strength glass fibers which are called as S glass, right? They were first used in a work which was carried out under the contribution of two different companies, two different industries. The one being the industry which was set up by Owens Corning, and the second was the United States Air Force. And what was the product actually? There they were mixing up this glass fiber, and they were utilizing this glass fiber to prepare some textiles which can withstand higher which can withstand higher pressures, higher temperatures, tough conditions. And they were also used these things to prepare components of aircraft industries, aircrafts, and so on, right? Then later somewhere around 1968, S2, the second category of under this S glass, S2 glass began evolving. That means whenever you have a product and you find some defects in those products or limitations in those products, you'll start to overcome those defects or limitations, such that you will be ending up with some other materials. One such material is nothing but our S2 glass, right? It's a subcategory. Fine. So this S2 glass, it started evolving in somewhere around 1968, and this has a very wide range of commercial applications, not limited to few, very wide range of commercial applications, right? And this high strength fiber glass or glass fiber, this gives properties in combinations like high strength combined with the high stabilities and transparencies and resilience at very reasonable cost to weight performances. What is this cost to weight performances? In a particular cost, we'll be getting limited amounts of weights due to reduction in the densities, and all such things will be like a combination of multiple amount of properties, not limited to one or two. It's a combination. Since it is a combination, it is providing us a combination of multiple properties. This high strength glass fiber is widely used till today in commercial applications, right? Moving on to the next slide. The utilities of these high strength glass fiber composites are compared. Of course, whenever you get a product, whenever you prepare a product, the first and important thing you will do is to compare the properties, compare the physical the performances or mechanical performances with the already existing components. Like the same way, in the likewise manner, the utilities of these high strength glass fiber composites were also compared by in regards to physical, mechanical, electrical, thermal, optical, and radiation properties with the already existing fibers, right? Then the glass fiber composites, the strength to weight ratio, though it is having less amount of density, as it is having less amount of density, the weight will be very less. It is limited to a particular ratio, right? The strength, though it is having very less density, though it is having very less weight, the strength even at that particular weight proportions will be very high. Therefore, the glass fiber composites will have high strength to weight ratios when compared to that of most of the other materials, and the impact resistance is phenomenal. That means impact. What is impact here? Again, the sudden loading. Resistance to withstand, the resistance to sudden loading or withstanding capacities towards against sudden loading will be phenomenal. That means it is much more than acceptable ranges. Okay, next, moving on to the next slide. Further, they also possesses since a material property is not limited to one or two categories, we can say that these high strength, low density or low weight glass fiber composites will also possess good electrical properties, resistances to moisture, and resistance against outdoor weather, like sometimes rainy seasons, the materials will come across, the material will be completely exposed to humid conditions, rainy conditions, wet conditions, and sometimes when you move on to midsummer seasons, the same material will be experiencing very heavy, very extreme temperatures, and sometimes like as the temperature increases, they will be exposed to huge amount of heat energies, and the materials, it is not necessary that the materials will be made use to prepare components which are not exposed to chemicals. We will be preparing components, we will be preparing machining components which will be subjected to chemicals. Therefore, they should also possess abilities to resist, abilities to withstand chemical properties, right? So, these properties are generally coupled with ease of fabrication. What is this ease of fabrication? Very easily we can fabricate whatever the machining component you require, whatever the product you want, whatever the thing you are planning to produce or manufacture or fabricate. By using this S-glass, by using this glass fibers, high strength glass fibers, we can easily fabricate it. That means though you are maintaining all the properties, the ease of fabrication will be maintained, right? Next, properties of glass fibers. We have lot of properties which can be listed out for any glass fiber, right? Among them, I am listing out here a few. You can have a look at this. The first being incombustibility, the second is corrosion resistance, the third is high strength even at low densities, and the fourth being good thermal insulations, fifth being sound insulation, and the sixth being special electrical properties. Let me give you a very short note about each and every of these properties. Incombustibility. Combustibility means they cannot be exposed, even though they are getting exposed to huge amount of thermal energies or heat energies, they cannot be subjected to combustibilities, right? So, they cannot catch fire. They don't catch fires that easily. Next, corrosion resistance. Even the material is exposed to extreme chemical conditions, we don't get corrosion or the material doesn't get eroded. Therefore, the material property, the glass fiber property, one of the important properties of these glass fibers is corrosion resistance, which is the most required for us to prepare huge amount of wide varieties of machining components or any sort of things. Next, as we have already discussed, the density. What is happening to density of a composite material? The density of a composite material will always be obtained at very low conditions, right? The densities will be very low. Even at such low densities, the strength is maximum. High strength even at low densities, right? Next, good thermal insulations. Sound insulation. Sound insulations is it is not allowing the sound to travel from one side to other side of that material. That means it is acting as a insulator, a sound insulator. It is the material which is absorbing all the echo, so it is acting as a damper. Okay. Next, special electrical properties. Because of these properties and because of the abilities which it is possessing, we are using glass fibers in a wide range of applications, right? Moving on to the next step. Types of glass fibers. In this types of glass fibers, I am actually categorizing this into two categories. Here in the slide, what you are observing is according to the type, right? According to the type, we are categorizing into these following categories. The first being A. We are designating this glass fiber with an alphabet capital A, and this capital A is indicating that the particular glass fiber what we are talking about is soda lime glass. So, soda lime glass is designated capital A. Electrical type borosilicate, we are also calling it as borosilicate, and borosilicate is being designated capital E here. And chemical resistant type, as we have already discussed in that properties of in the slide which is discussing about properties, we are saying all the materials are chemical resistance, right? So, the chemical resistance is designated capital C, which is talking about materials which are resistant towards chemicals, erosions or so, and alkali resistant type AR, and next high performance applications capital S, right? In the previous slides what we have discussed, high strength performances, S glass, S2 glass, all those things are categorized under this high performance application types, right? Next, according to the grades, Till now we have discussed according to the type, now according to the grades. According to the grades, we are broadly classifying the glass fibers into 5 categories. And what are those 5 categories? General purpose glass fiber, quartz fiber, protective fiber, hollow fiber, and conducting or semi-conducting fiber. So these are the 5 different categories of glass fibers under grades. So basing on grades, we are classifying those into 5 different types, and basing on types, we have categorized it into 6 different types. Sorry, 5 different types, as we are seeing here: A, E, C, AR, and S. Right. Now, moving on to the next slides. Here we have the various properties. You can clearly observe in this tabular column. In this tabular column, we have compared the properties of 3 different categories of glasses. The first being E glass, the second being AR glass, and the third being S glass. What is E glass? If you don't remember, I'll just in a glance I'll go to the previous slide so that you can again have a glance at it. We can categorize all the 3 things: E glass being electrical type, AR being alkali resistant type, and S being high performance applications type. Okay, now we'll go back to the slide. Here, observe carefully, pay much attention here, because we are comparing different types of properties between 3 different categories of glasses: E glass fiber, AR glass fiber, and S glass fiber. The first among this is tensile strength. What is this tensile strength measured in? Tensile strength is always measured in gigapascals, GPa, right? What about tensile strength? Observe carefully that the tensile strength of E glass and AR glass, electrical type glass and alkali resistant type glass, are almost same, approximately same, 3.5 gigapascals. But when you move the same to the other one, that is nothing but our S glass here, it is observed as 4.6 gigapascals. That means the tensile strength of the high performance application type is obviously more when compared to the other 2 categories, the first being E glass and the second being AR glass. Okay, next, modulus. Modulus is also measured in terms of gigapascals, and you can observe the values of E glass being 73.5 gigapascals and AR glass being 175 gigapascals. But when you come to S glass, that S glass high performance type is having a bit less modulus, that is limited to 86.8 gigapascals. Next, the third property, elongation in terms of percentages. When you apply some tensile forces, an object will undergo elongation, right? Let us say that elongation is obviously taken in terms of percentages. The elongation of this E glass, which is nothing but electrical type glass, it can be obtained approximately to about 4.8%, whereas in case of AR glass, alkali resistant gas, it is taken up to glass fiber, it is taken up to 2%, and regarding the S glass, that is high performance glass, it is obtained up to 5.4%. And density, the densities of these 3 particular fibers, glass fibers, are also compared, and the density of E glass being 2.57 grams per cubic centimeters, and the density of alkali resistant being 2.68 grams per cubic centimeters, and for the S glass it is being 2.46. See, you can clearly understand here, you can clearly analyze that the density of this particular S glass, high performance glass, is a bit low when compared to the other types. Though the density is low, go back to the first property, tensile strength is high. Though the density is low, tensile strength is high. That's the reason we are calling S glass as high performance glass or high strength low density glass, right? Next, we have refractive index and coefficient of thermal expansion and dielectric constant, and all these properties are generally compared between these 3 categories. Okay, now the final topic of today's class, manufacturing of glass fibers. What is this manufacturing of glass fibers? How do we manufacture a glass fiber? This glass fiber, there are multiple procedures in preparing these glass fibers, but here in this diagrammatical representation you will clearly observe the most important and the most widely used manufacturing process of this particular glass fibers. Here you can observe that there are 2 storage tanks, and those storage tanks are nothing but our raw material storage tanks, and from that raw material storage tanks we will be collecting glass material. right? And that glass material will be heated up such that we will be supplying molten glass or glass which is in form of molten state. We will be supplying molten glass which is somewhere at around a temperature of 1370 degrees centigrade, 1370 degrees centigrade, and this will be supplied to a furnace, and after furnace, through the furnace, the molten material will be flowing onto the through the refiner, and finally it will be coming to the forehead. Okay, and after this complete process is done, the temperatures will be slightly cooled down or will be brought down such that from 1370 degrees centigrade, the molten material continuously gets cooled to a temperature of 1260 degrees centigrade. At this 1260 degrees centigrade, the glass which is in semi-solid state, it is neither completely liquid, it is not completely solid. The glass which is in semi-solid state will be drawn, so that we will be getting wires, glass wires, which are nothing but our fibers, right? So we will be drawing the wires, and those wires here, the winders, what you are observing here, those are nothing but our creels. Okay, the wires, the wire-like substances which are being drawn from the molten glass material will be wounded onto these creels, which can be directly used for fabrication purposes, or which can be directly used as reinforcement materials, right? Moving on to the next slide. Here I have given you just a very brief theoretical description about the same thing what I have explained you, manufacturing of glass fibers. First we will be mixing, first we will be getting the material melted. How? Before melting it, we will be mixing different elements like silica, the first one, and silica sand obviously, the limestone, the boric acid, and other minor ingredients, so that the complete mixture, when supplied with heat energy, it gets heated up, and one form of material gets converted to other form of material by releasing the heat energy, so that the internal energy increases, and finally the glass material, which is our raw material, will start melting. And this melting will be taking place about 1260 degrees centigrade, and we will be letting the molten glass flow through the fine holes. Obviously it is taken, the complete mold is taken a platinum plate, because the thermal properties will be obviously high for that, right? And then after that, the glass which is in molten state will be let to cool down, and then it will be drawn into wires, and those wires will be initially be given a protective coating. Why we are giving a protective coating? For avoiding many things like corrosion, to avoid corrosion, to avoid getting exposed to harsh conditions and all such things, right? To avoid such things, we will be giving a protective coating here, and after that protective coating, the fibers which will be gaining directional strengths, in which direction we will be, drawing it, depending upon that they will be gaining some directional strengths, and those fibers will be either wounded onto a creel, or they will be directly woven into various forms, so that those various forms will be forming fabrics. So as I said you in the previous classes, we can use fibers directly from the creel, or even we can also use fabrics in order to prepare a composite laminate or laminate. Okay, so with this I am just closing the session for today, and in tomorrow's class we'll start discussing about different types of glass fibers and how to deal about the manufacturing processes along with their applications and properties, right? Thank you. Let's meet in the next class.